Good morning, students. Am I audible?
Yes, sir.
Okay, thank you. I think in the last class we have already discussed this numerical, right? This is done, right? Yn equal to 1.189, q multiplied by n divided by root over base slope to the power 3 by 8. We have already derived this one, right? In the next last class. Okay. And this numerical, what about this numerical? No, sir. Okay, fine, fine. So we are going to discuss the next numerical as this. Okay. So in this numerical, what is given? We need to derive an expression for k for a triangular channel. Okay, for a triangular channel, and the side slope of the triangular channel is 2 horizontal is to 1 vertical. It's given. Okay, and we have to derive this equation that k is equal to, for that particular triangular section, is 1.169 y to the power 8 by 3 divided by n. Okay, so we have to derive this. We have to show that if for k, for a triangular channel, when the side slope is 2 horizontal is to 1 vertical, then that k value will be this, that is 1.169 y to the power 8 by 3 to the power n. Okay, so this is our triangular channel. Side slope is, we have considered 1 is to z. Okay, so definitely we have already discussed this will be your zy, and the other part is also again zy. Okay, these things we have already discussed. Okay, so here that 1 is nothing but your vertical. Okay, and z is nothing but your horizontal. Okay, so what is given is 1 vertical is given is equal to 2 horizontal is given in the question. So from here you can say our z is equal to, okay, that is why our z is equal to 2. So in place of z we can directly substitute is equal to 2. Okay, so first we have considered the area equation, that is half into base into altitude. So half, this will be base multiplied by y. Okay, so it will be area equal to zy square, and we know z is equal to 2. Then we have substituted and we got twice y square. Okay, okay, then we need to find out the weighted perimeter. So weighted perimeter of a triangle channel, we have to consider this side and this side, right? So as the slope is same, so we need to find out one side and then we can multiply it by 2. You'll get the weighted perimeter of the triangular channel. So that is why we have used Pythagoras theorem. Those things we have already discussed. So that is why we have multiplied by twice, then root over this side square plus y square. Okay. After simplification, you will get weighted perimeter is equal to twice y root over 5. That is your weighted perimeter for that particular numerical. Okay, then we need to find out k, expression for k. And if you remember, k is nothing but our discharge by root over slope. That is your bed slope. Okay. So suppose velocity equation is 1 by n r to the power 2 by 3 sb to the power half. Okay. So this is our velocity equation using Manning's equation. Okay. For velocity using Manning's equation. So here, in place of velocity, we all know discharge equal to area into velocity. Area multiplied by velocity. So in place of velocity, we can write Q by A. That is discharge by area. So here we are going to substitute Q by A. Okay. 1 by n r to the power 2 by 3 sb to the power half. Okay. So we can bring that base slope in the left hand side. Okay. It multiplied, it will be divide if we bring in the left hand side. Okay. So what will be left out? A r to the power 2 by 3 to the power n. Okay. So this is nothing but your k. This is nothing but your k. So directly you can write k is equal to a r to the power 2 by 3 divided by n. So for velocity, why we have used Manning's equation? Because the expression you go in a numerical, the expression given in the numerical, what we have to derive, we have small n. Okay, we have small n. So that is why we are using for velocity Manning's equation. Because whatever the equation we are going to get, there should be, we should have n. Okay, now you substitute all the terms. Okay, that is area expression that we have already derived, zy square, or you can directly write twice y square. Okay, r is nothing but area by weighted perimeter. Okay, area we have derived, that is zy square. Weighted perimeter is nothing but this, twice y root over 5. Okay, so in place of z you can directly write 2 twice y square. So this 2 will be cancelled out. Okay, and you do the simplification. So you try, do the simplification and see you are getting this value or not, or this expression you are getting or not. In place of area, you directly substitute twice y square. R is equal to a by p. So area you again write twice y square, and this will be your twice y root 5. Okay, to the power 2 by 3 divided by n. Then you further simplify and see you are getting that expression or not. So if it is over, then we will move on to the next. Okay. Okay. So next topic is computation of hydraulic exponent. That is your capital N. Okay. That is your next topic. Okay. Next topic is computation of hydraulic exponent. That is your capital N. Okay. So here we are going to derive an expression for your hydraulic exponent. That is your capital N. So we can use two method. One is using Sage's equation and one is using Manning's equation. Okay. So that expression for N, if we use Sage's equation, it's a little bit different than when we use Manning's equation. Okay. So that first case, we are using Sage's equation. Okay. So you kindly write down the derivation. You write down the topics as computation of hydraulic exponent, capital N. You can write in an uniform flow. Okay. First case, when Sage's equation is used. Okay. Then you all know this expression that discharge is equal to area into velocity. Okay. And then in place of velocity, we are going to use Sage's equation. So Q equal to area, and we know that velocity we are going to use Sage's equation, that is Sage's constant root over r hydraulic radius multiplied by slope. That you can say it is a bed slope. Okay. This is our next expression. Okay. Then K we have already discussed. K is nothing but Q by, it will be Q by root over SB. Okay. So it will be left out with area C and then multiplied by root over R, or you can write R to the power half. Okay. Okay. So K is nothing but your discharge divided by root over bed slope. Okay. So you substitute it as a equation 1. Okay. Put it equation number 1. After equation 1, you write down this line. Okay. A and R is the function of depth y. Definitely, if you see whatever the area equation you write, for suppose for a rectangular channel, area equal to width of the channel multiplied by y. Okay. So what happen if you change the y value, your area will be changed for the same cross section, or you can say for the same channel. If you change the y value, or if there is a difference in depth of flow, we can say our cross sectional area is also changing. So that is why our area is a function of y. Okay. And so as for hydraulic radius, so hydraulic radius is nothing but your a by b. Okay. So definitely area and weighted perimeter. If you consider a rectangular channel, suppose your depth of flow is here in first case and then it reduced to here, definitely your area and weighted perimeter will also be change. Okay, so that is why our area and weighted perimeter, sorry, hydraulic radius is also a function of y. Okay, so you can write down this line. Since a and r is a function of y, the relationship between k and depth of flow, the relationship between k and depth of flow can be written as you can write this equation k square equal to c dash y to the power n. Okay? You can write this equation. Okay, written that is k square equal to c dash y to the power n. Okay, whereas c dash is nothing but your constant, that is capital N is nothing but your hydraulic exponent for computation of uniform flow. Okay, that capital N is nothing but your hydraulic exponent for computation of uniform flow. Okay, now we are going to take log. Okay, so we have this equation k square c dash y to the power n. Okay, so now we are going to take log on both the side of this equation. Okay, so here also we have considered log. So if we take log, it will be twice log ek is equal to log e c dash plus n log e y. Okay, okay. So this logarithm is done. Okay, now we are going to differentiating with respect to y. We are going to differentiating this above equation, this equation with respect to y. Okay, so this was the original equation. First we take log, then after taking log we are going to differentiate this equation with respect to y. Okay, so if you do consider this equation, this is some, there is some error. You can write after differentiating you will get like this. Okay, twice to the y log e k. Okay, log e and then it's k is equal to, definitely c dash is a constant. If you differentiate log constant until it's 0. Okay, then n plus, sorry, n divided by y. Okay, so if you further simplify it will be something like that. Okay, dy log e k is equal to n by twice y. Okay, we bring this y in right hand side. Okay, this is your final expression, and you can consider this is equation number 2. Okay, so what we have to do in this equation, first we have to take log, then we have to differentiate that equation with respect to y. Okay, here if you don't write this 0, then it is correct. Okay, dy dy log e k is equal to n by twice y. This is our final expression. Okay, number 2. Now see, we have one equation here. K is equal to AC r to the power half. Okay, now see, our intention is to derive an expression for this n value, for this n, that is your hydraulic exponent. Okay, so in equation number 2 we have dy dy log e k is equal to n by twice y. Okay, so we have n. Okay, then in first equation, what we do here also, first we are going to take logarithm in both the side, then we are going to differentiate with respect to y, so that in the left hand side we are getting that same expression as equation number 2, that is d by dy log e k, and then we can equate both the equation, just to replace this left hand side of equation 2, so that we can get an expression for our hydraulic exponent. Okay, so that is why the next step is to take logarithm in equation number 1. So our equation 1 was A is equal to area multiplied by C r to the power half. Okay, so this was our equation 1. Now we are going to take log both the side. Okay, so this will be again log e k. Okay, so we have constant C log e c. Then we have area. So it is multiplied, that is why if you take log, it will be addition. Okay. So that is why log EA. And the last term we have to the power half. So half will be here and then log ER. Okay. So now we have to differentiate with respect to y. Differentiating with respect to y. Next step. Okay. So it will be d by dy log ek. Okay. Is equal to c is nothing but your constant. Z is constant. So that is why it will be 0. Okay. So differentiating log e, so log a, so it will be 1 by a. Log a is 1 by a. Differentiating log a is 1 by a. And see, this area is again a function of y. Okay. If it is in place of area, if it is we have y, then we can directly write 1 by y. Okay. As this area is not y, or area is a function of y, so again we have to differentiate area with respect to y. So that is why, for if we differentiate log a, it will be 1 by a. As area is again a function of y, so it will be again dA by dy. Okay. This is a simple mathematics. Then addition, we have log er. Again, for log er, so this will be constant half. Then for log er will be 1 by r. And then r is again is a function of y. So we have to differentiate again with respect to y. So that is why dr by dy. This is simple mathematics you have learned. Okay, in differentiation. So if you see that equation number 2, the left hand side we have d by dy log ek. Okay, here also same. So what is our intention? To equate these two equation so that we can get an expression of n, so that we can derive an expression for n. That is our hydraulic exponent. Okay. So say if you consider a channel and we have considered a small elementary area. Okay. So if you want to find the top width, okay, so if you consider it's a rectangle channel, so dA is the area. Definitely it will be b into y. B is nothing but your top width multiplied by dy. So you can write in place of top width dA by dy. Okay. Okay. So here we have dA by dy in this equation. So that dy by dy we are going to replace by top width. Okay. And R is going to replace by area by weighted perimeter. That we all know. R is equal to weighted by, sorry, area by weighted perimeter. You kindly write it down. Okay. over. So this left hand side will be the same. It will remain same. Then 0 is there. Okay. Then next is your 1 by a dA by dy. So we have already discussed that dA by dy. In place of this, we can write top width. So here, that is a top width by area. Okay. Plus the last term, in place of r, we have replaced by area by perimeter. Okay. Area by perimeter, weighted perimeter. Okay. So what we have to do next, it always remain same. Okay. And then you see this term. Okay. 1 by twice r is constant, no issue. Okay. Here we have to differentiate a by b with respect to y. Okay. So if you remember, in differentiation we have two formula. One is u by v and one is u multiplied by v. Okay. If you want to use this u by v, so it is same as a by b. Okay. Your u will be a and p will be v. Okay. So that you can directly apply here. Or if you want to use this expression u multiplied by v, then what you have to do, you have to take p to the power minus 1 multiplied by area. Okay. P to the power minus 1 and area. So then you can take this as u, this will be u and this will be p. Okay. So any one of you can do and you find out this. Okay. So I suggest you kindly see you are getting this or not. Okay. After applying this formula u by v or u multiplied by v, it's up to you which one you want to do. Okay. If you get this, then it's okay. Then we'll move on to the next line. Okay. But you should try. Okay. It's a simple differentiation. You can consider u by v formula or u multiplied by v. Okay. Any doubts, students? You're getting this expression? Okay, see, this is the expression, okay? Or this is a 1 by twice r. We need to differentiate a by p with respect to y. Okay? So we will keep that constant twice r bracket. Okay? So u by v, I'm going to use u by v. Okay? U by v is nothing but your v multiplied by u dash minus u multiplied by v dash divided by v square. Okay? This is the formula, and I think all of you know this. Okay? This is a very simple and popular formula for derivation. Okay? For differentiating u by v. Okay? So here our v is nothing but our p. So we write p. Okay? Then u dash. matlab we need to differentiate u with respect to y. Okay? So u is nothing but a. So dA by dy. Okay? Then minus area dp by dy. Okay? Divided by p square. That is p square. Okay? Done. Next, you see 1 by twice r. If you further simplify this, here we have p and here is p square. Okay? So it will be dou a by dou y, and we'll be having 1 by p. We'll be having 1 by p here. Okay? Then minus a by p square. Okay? Then right here a by p square dp by dy. Okay? Done. So here, if you multiply, see, then we have to 1 by twice where we have to multiply for both the part. Okay? That is why 1 by twice square multiplied by 1 by p, 1 by p dA by dy. Okay? Then again we have to multiply 1 by twice here also. So that is why minus a by twice r 1 by p square. That is a by p square is already there dp by dy. Now it's clear. Okay. Yeah, this meeting is going to end. So we will continue in the next class. Okay. That is from 10:15. Okay. There will be a 5 minutes break and we will continue from 10:15.